Look at this car. It's a sleek, modern electric vehicle, equipped with the technology and driving range expected from the future of transportation. In its domestic market, a consumer can walk into a showroom and drive this exact model home for roughly €7,200. That price is roughly one-fourth the cost of a comparable entry-level EV in Europe. It represents a manufacturing gap that traditional Western production models are currently incapable of closing. It is easy to assume a number that low is the result of cheap labor or basic government handouts, but the actual math is more complex. To understand how a €7,200 price tag is possible, we have to look past the vehicle itself and reverse engineer an industrial strategy decades in the making. Let's strip the car down. In any electric vehicle, the battery pack is the single most expensive and critical component. This chart shows global battery manufacturing capacity. China's 85% share means this sector has a single primary point of origin. Within that share, two companies control the majority of the market: CATL at 37.9% and BYD at 17.2%. This advantage is built on specific chemistry. For the affordable lithium iron phosphate, or LFP batteries used in mass-market cars, Chinese production accounts for over 98% of the global total. By capturing almost total control over the most affordable battery chemistries, China owns the financial bottleneck of the global EV transition. Refining those battery components and running massive factories requires a constant, heavy supply of cheap baseload power. To provide that power, China currently operates 59 nuclear reactors, producing about 62 gigawatts of electricity. The momentum is increasing. China is building half of all the nuclear reactors under construction worldwide. But those reactors and factories are useless without the raw ore required to feed them. Between 2000 and 2021, Chinese mining investments in emerging countries reached approximately $57 billion. That capital secured control over the specialized elements used in modern tech, including 99% of all heavy rare earths processing. This systematic cornering of the raw material supply chain was completed long before most global competitors noticed the shift in the market. We can now see the loop in motion. It starts with $57 billion in foreign investments, extracting 99% of heavy rare earths from the ground. That ore is shipped back and refined by an industrial sector powered by a grid of 59 nuclear reactors. Those plants produce 98. This is total vertical integration, owning every step of the process, from the raw minerals to the finished vehicle in the showroom. Western automakers are facing the full weight of a state-level industrial machine. To compete with this price, they have to match an entire integrated ecosystem, rather than a single company. Until they address that whole system, the price gap will remain.